Hello students, I hope you are doing fantastic out there. So we are ready to start exercise 22B. We have already completed exercise 22A in our previous videos. So today in this video we'll start exercise 22B. Okay, so this is exercise 22B, question number 1. Okay, we will solve each and every question of this chapter as well. So let's begin. Let us first read out the question, understand the instruction of the question, and then we will proceed to solve. Okay, in the figure given below, it is given that AB is perpendicular to BD and is of length x meters. So let us understand the question. This is the figure. AB, the line AB is perpendicular to the line BD, means the angle between the line AB and BD is 90 degree. Okay, perpendicular means the angle between the two lines is 90 degree. Further, the length of AB is x meters. AB is x meters long. Okay, and DC is 30 meter. You can see the distance between the point C and D is 30 meters. Angle ADB is 30 degree, means angle ADB, angle D is 30 degree. Okay, ADB, this is 30 degree, and angle ACB is 45 degree. ACB, this angle, C should be in the middle. ACB is 45 degree. So we are asked to find the value of x. X means the height, okay, the length of AB, x, without using trigonometric tables. So let's begin. First of all, what we do is we take triangle ACB. Okay, in triangle ACB, in this triangle we have AB equals to x, isn't it? X meters, and angle ACB, C should be in the middle. Okay, angle C, angle ACB means angle C equals to 45 degree. This is given to us. So using tan theta we can find BC, isn't it? Because we know that since tan theta is perpendicular upon base, so tan of angle ACB, this angle, okay, tan of angle ACB is perpendicular is AB and base is BC, isn't it? So perpendicular AB by base BC, or you can write CB as well. Okay, or tan of angle ACB is given to us 45 degree, isn't it? So AB, we know AB is given to us, AB is x meters, and BC we are trying to find BC. Or tan 45 degree means the value of tan 45 degree is 1. Okay, so equals to x upon capital X, isn't it? X upon BC. Now let us cross multiply this. BC into 1 is BC. BC equals to x. So this is equation 1. This means the distance between the point C and B is x meters. This is x meters long. Okay, now from triangle ADB, means the bigger triangle, isn't it? From triangle ADB we apply tan theta. Here also the perpendicular will remain AB, but the base will be BD. Okay, so in triangle ADB, AB equals to x, that is perpendicular, okay, x meters, and angle ADB means this angle, isn't it? ADB, make sure D should be in the middle. We are talking about angle D, equals to 30 degree. So applying tan theta, since tan of angle ADB equals to perpendicular is AB, isn't it? AB, perpendicular is common for both the triangles, triangle ACB and triangle ADB. Okay, perpendicular is common for both the triangles. So perpendicular AB by base is, here base becomes BD, isn't it? Because we are talking about the bigger triangle. ADB, base is BD. BD. Or tan of angle ADB is given to us 30 degree, isn't it? We write 30 degree. Let me start from here, okay? Tan of angle 30 degree equals to AB. We know AB, that is x. AB is x. And BD means BC plus DC. Or you can write CD, okay? CD. Same thing. Tan 30 degree equals to perpendicular upon base. Perpendicular is AB, AB is x, and BD is DC plus CB, isn't it? BD, total BD means DC plus CB. DC is CD, okay? DC is CD and BC is BC, okay? CB is BC. You can write CB or you can write DC. Whichever way you write, both are correct, okay? Tan 30 degree means 1 upon root 3, isn't it? So let us put the value of tan 30 degree, 1 upon root 3 equals to x upon BC. We know the value of BC from equation 1. BC equals to x. So we put the value of x plus CD is given to us. CD is DC. DC is 30, isn't it? So now let us cross multiply this. X plus 30 into 1. X plus 30. Oh, capital X, isn't it? X plus 30 into 1. X plus 30 equals to root 3 into x. Root 3 x. Capital X. Capital X. Okay. X plus 30. X plus 30 into 1. X plus 30. Root 3 into x. Root 3x. Now we keep this 30 in the left hand side and take this x to the right hand side, okay? Root 3 x minus x. This plus x when taken to the right hand side becomes minus x equals to 30. I hope you are getting me. Now let us take the common out, that is x. Then what remains within the bracket? X into root 3. X into root 3 is root 3x. Plus into minus is minus. X into 1 is x equals to 30. Or x equals to 30 is already in the right hand side. So we take root 3 minus 1 to the right hand side. By cross multiplication it goes to the denominator. Root 3 minus 1. So the value of x is this, but we cannot keep the number having root in the denominator, okay? So let us rationalize this number. How do we rationalize? We just write root 3 1, okay? But the sign here is minus, so we write plus. So we multiply and divide by root 3 plus 1. If we have root 3 plus 1 here, we write root 3 minus 1 upon root 3 minus 1. Here we have root 3 minus 1, we write root 3 plus 1 by root 3 plus 1. Multiplying and dividing by root 3 plus 1. The value of this number does not change when we do this, because this and this can be cancelled and we get 1, isn't it? Or x equals to 30 into root 3 plus 1. 30 into root 3 plus 1, isn't it? So here we have a minus b into a plus b, that is a square. A, root 3 is assumed as a and 1 is assumed as b, okay? So a minus b into a plus b is a square minus b square. So root 3 square means 3, isn't it? Minus 1 square means 1. Root 3 square is 3, okay? Root x square is x. Root x square is x. When we square, the square and the root cancels out, only the number remains, okay? So root 3 square is 3 and minus a square minus b square means a square. Root 3 square 3 minus b square means 1 square is 1, okay? So I hope you got this. Now let me continue. Let me erase this, okay? Please take the screenshot. I am erasing this. So x equals to we are asked to find the value of x, isn't it? X equals to 30 into root 3 means 1.732, isn't it? Plus 1 divided by 3 minus 1 is 2. So 2 1s are 2, 2 15s are 30. Or x equals to 1 plus 1. So 15 into 1. This 1 is before a decimal point. So we must add with the number before a decimal point. Okay. So 1 plus 1 is 2 point. After decimal point we have 732, isn't it? 732. So we multiply this and the value of x will be that. 15 2s are 30, 0. We write 3 in hand. 15 3s are 45, 45 plus 3 is 48. So 8, 4 in hand. 15 7s are, so 15 6 are 90, isn't it? So 15 7s are 105. 15 7s are 105 plus 4 109. So 9, 10 remains in hand. 15 2s are 30, 30 plus 10 is 40. So we have a decimal point before 3 digits. So we put a decimal point before 3 digits. 1, 2, 3. So the value of x is 40.980. That means x equals to 40.980. 0 we don't write, okay? After decimal point, 0 has no value. But if there is a number, non-zero number after this 0, then we must write this 0, okay? So we were asked to find the value of x. Value of x is 40.98. I hope you got this. Now let us move on to the next question. 2 of exercise 22b. Find the height of a tree when it is found that on walking away from a 20 meter in a horizontal line through its base, the elevation of its top changes from 60 degree to 30 degree, okay? So let's draw the diagram and understand the question better, okay? And then we will proceed to solve. So let us assume this is a tree and this is a horizontal ground, okay? Suppose the point is this. When observed from this point, the angle of elevation of the top of the tree was 60 degree. I'm just assuming this, okay? When observed from this point, the angle of elevation of the top of the tree is 60 degree. This is given to us, 60 degree. Now, if you move 20 meters away along this horizontal line, 20 meters away means suppose this point. If you move 20 meters away from this point, okay, and observe the top of the tree again, at this time the angle of elevation is changed to 30 degrees, isn't it? Angle of elevation is changed to 30 degree. Let me write this point here, okay? This is 30 degree. When observed from this point, the top of the tree, the angle of elevation was 60 degree. From this point, when one moves further 20 meters away along the line of the base and observes the top of the tree again, the angle of elevation made at the time is 30 degree. So we are asked to find the height of the tree, okay, AB. We are asked to find AB, the height of the tree. The question is, find the height of the tree, AB, okay, AB. We are asked to find the height of the tree, AB. So let us suppose the height of the tree be X. This is A, this is B, so C, and this is D. We name this, okay. Now let us solve this question. Let us first take triangle ABC, the smaller triangle. When we take triangle ABC, AB will become the perpendicular, BC will become base, okay. When we take triangle ABD, the bigger triangle, at this case also AB will remain as perpendicular but base will become BD, okay. When we talk about the bigger triangle, base will BD but the perpendicular will remain AB. But right now we are talking about triangle ABC, the smaller triangle. Okay. in triangle ABC, okay, AB equals to height of the tree, isn't it? Height of the tree equals to x meters, say. We are supposing the height of the tree AB is x meters, okay? So, and angle ACB, make sure C should come in the middle, okay? ACB, angle C, ACB is 60 degree. ACB is 60 degree. Now, let us apply tan theta and find BC, okay? So, since tan of angle ACB, when we talk about tan of angle ACB, perpendicular becomes AB and base becomes BC, isn't it? So, perpendicular AB by base BC, okay? So, tan ACB means we have 60 degree equals to AB means x, isn't it? We have supposed the value of AB is x. BC, we do not know the value of BC. We are trying to find BC, okay? So, tan 60 means we put the value of tan 60, that is root 3 equals to x upon BC. Or let us cross multiply this. BC comes here, root 3 goes down to the denominator. BC equals to x upon root 3. Let us assume this as equation 1. We found the value of BC. BC is x upon root 3, isn't it? This BC, distance between the 2 points, BC is x upon root 3. Okay. Now, from triangle ABD, okay, in triangle ABD, the bigger triangle ABD, AB is perpendicular, isn't it? AB equals to x, the height of the tree, and angle ADB is 30 degree. 30 degree, isn't it? So let's apply tan theta. Since tan of angle ADB equals to perpendicular is AB, isn't it? I told you earlier, perpendicular remains common for both the triangles ABC and ABD. Perpendicular is AB and base is BD. Okay, in this case, when we talk about the bigger triangle, base becomes BD. Okay, or tan of angle ADB means we have 30 degree, isn't it? We write 30 degree equals to AB. AB we have found, AB, we have found AB as x. We have supposed AB as x, isn't it? AB as x. BD means BC plus CD. BD means BC plus CD. Total BD is BC plus CD. BC plus CD gives us BD. So tan 30 is 1 upon root 3, isn't it? Equals to x upon BC. The value of BC is x upon root 3 from equation 1. BC is x upon root 3 plus CD. CD is 20 meter. 20 meter, isn't it? We don't write unit, okay, right now. 1 upon root 3 equals to, so x upon, let's take the LCM, root 3 and 1, the LCM is root 3. 1 into x is x plus root 3 into 20 is 20 root 3. Okay. Now let us cross multiply this. First of all, let us take this x to the root 3 to the numerator, okay, or 1 upon root 3 equals to, this root 3 goes to the numerator, x into root 3 upon x plus 20 root 3, isn't it? X plus 20 root 3. This root 3 goes to the numerator, x into root 3, and in the denominator we have x plus 20 root 3. X plus 20 root 3. Now let us cross multiply this. x plus 20 root 3 into 1, x plus 20 root 3 equals to root 3 into root 3, that is 3. This x comes here as it is. Okay, root 3 into root 3 is 3. Root x into root x equals to x. Okay, root a into root a equals to a. So root 3 into root 3, 3. So this x comes here as it is. Now we keep this 20 root 3 here, 20 root 3, and this 3x we already have in the right hand side. Let us take this x to the right hand side, minus x, or 3x minus x is 2x, we write here, equals to 20 root 3, isn't it? So x equals to 20 root 3 upon 2. 2 ones are 2, 2 tens are 20, isn't it? So let me continue here. Please take the screenshot. Or x equals to 10 into root 3. This 2 is cancelled. We have 1 in the denominator. 10 into root 3. 10 into root 3. Root 3 means 1.732, isn't it? Or x equals to 1 into 1.732 is 1732. So we have 0 here. When multiplied with this, the decimal point shifts to the next number, isn't it? So 17.32 meters. Okay, we found the value of x, and x is the height of the tree, isn't it? So therefore the height of the tree is the height of the tree equals to 17.32 meters. I hope you got this. Now let us move on to the next question. 3 from exercise 22b. Find the height of a building when it is found that on walking towards it 40 meters in a horizontal line through its base, the angular elevation of its top changes from 30 degree to 45 degree. Okay, so let's understand this question by drawing the diagram. So this is a building. Let us suppose this is a building, okay, and this is a horizontal line. Now when observed from a certain point here, let us say this point, okay, when observed from this point, the angle of elevation was 30 degree. The angle of elevation was 30 degree. Now on moving 40 meters towards the building, okay, from here on moving 40 meters towards the building, means suppose this is 40 meters, from here to here is 40 meters, okay, the angle of elevation is changed to 45 degrees, isn't it? The angle of elevation is changed to 45 degree. Okay, so let's join this. When observed from this point, the top of the building, this is A, suppose, when observed from this point, the top of the building, the angle of elevation was 30 degree. Now on moving 40 meters towards the building, isn't it? Building is here, towards the building. Now again, when observed from this point, the top of the building, the angle of elevation changed to 45 degree. Okay, the distance from this point to this point is 40 meters. So we are asked to find the height of the building, isn't it? Find the height of the building. So let us say this is A, this is B, this is C, and this is D. Okay, AD is the height of the building. Let us suppose X. Let us take a smaller triangle first. Okay, ACD. In triangle ACD, AD is the height of the building, isn't it? AD equals to height of the building, height of the building equals to X meter, say X meter, say. Let us suppose the height of the building is X meter, AD. Okay, now angle ACD, this angle, isn't it? ACD is 45 degree. ACD equals to 45 degree. Now we have perpendicular, we have angle, we can find base CD, isn't it? So applying tan theta, since tan of angle ACD equals to perpendicular AD by base CD, or tan of angle ACD is given to us, that is 45 degree, equals to AD means x. We have assumed the value of AD is x. CD is not known to us. We are trying to find CD. Okay, we write CD. So tan 45 means 1, isn't it? Equals to x upon CD. Or CD into 1 is CD. CD equals to x. So this is equation 1. So the value of CD, distance between the 2 points C and D, is x meters. Okay, this is x meters. Now let us see the bigger triangle ABD. Perpendicular is common to both the triangles. Okay, ACD and ABD triangle. Sorry, perpendicular is common. AD is common to both the triangles. So base is BD for the bigger triangle, isn't it? In triangle ABD, AD equals to x. We know AD is the height of the building, that is x, and angle ABD is 30 degree. Angle ABD equals to 30 degree, isn't it? Now since tan of angle ABD equals to perpendicular upon base, isn't it? So perpendicular is AD upon base is BD, okay, or tan of angle ABD 30 degree, we put the value of ABD, that is 30 degree, equals to AD means x, isn't it? So BD means, total BD means BC plus CD gives us BD, that is BC plus CD, okay. Or what is the value of tan 30? 1 upon root 3 equals to x upon BC. BC is 40 meter, we write 40 here, plus CD. CD is x, isn't it? CD is x from equation 1. CD is x. Now let us cross multiply this. 40 plus x into 1. 40 plus x. 40 plus x into 1 is 40 plus x, equals to root 3 into x is root 3x. Okay. Now let me take this root 3x here. Root 3x plus x, when we take to the right hand side, becomes minus x, equals to 40 remains here. Okay, 40. Now we take x common, or x is taken common, x and x. Within the bracket remains root 3 minus 1, isn't it? Root 3 minus 1. X into root 3, root 3x, plus into minus, minus x into 1, x, okay, equals to 40. Or x equals to 40 is already in the right hand side, so root 3 minus 1 goes to the denominator by cross multiplication. Let us rationalize this. We have root 3 minus 1, so let us multiply and divide by root 3 plus 1. Root 3 plus 1, okay. Or x equals to 40 into root 3 plus 1, 40 into root 3 plus 1 divided by root 3 minus 1 into root 3 plus 1. This is a minus b into a plus b. We assume root 3 as a and 1 as b, okay. A minus b into a plus b is a square, that is root 3 square is 3, minus b square, 1 square is 1. Or x equals to 40, root 3 means 1.732, okay, the value of root 3 is 1.732 plus 1 divided by 3 minus 1 is 2. So 2 1s are 2, 2 2s are 4, 2 0s are 0. Now please take the screenshot. I'm going to erase this, okay. So x equals to, or x equals to, we have this 2 is cancelled, we have 1 in the denominator, so we need not write this one. 20 into 1.732 plus 1. This 1 is before the decimal point, so we must add with this one which is before the decimal point. Okay, 1 plus 1 is 2, 2.732. 1 plus 1.732 is 2.732, or x equals to, let us multiply this, 2 2s are 4, 2 3s are 6, 2 7s are 14, 2 2s are 4, 5. Okay, now this 0 comes here, 20 has 1 0, so we put this 0 here. There is a decimal point before 3 digits, 1 2 3, so we put a decimal point before 3 digits, 1 2 3, 54.640, or x equals to 54.64, isn't it? 0 has no value, so we don't write that. 54.64. This means x is the height of the building, isn't it? Therefore, the height of the building equals to 54.64 meters. Okay, now let us do the next question. Let's do question number 4. From the top of a lighthouse 100 meter high, the angles of depression of the two ships are observed as 48 degree and 36 degree respectively. Find the distance between the two ships in the nearest meter. Nearest meter means we should not consider decimal points, we should round up the number. Okay, question number 1 is the ships are on the same side of the lighthouse, and number 2 is the ships are on the opposite side of the lighthouse. Let us understand this question first by drawing a diagram. Question number 1, okay, the ships are on the same side of the lighthouse. Suppose this is a lighthouse and this is a horizontal line. Horizontal line means you can say this is a water body. Okay, the two ships are coming towards the lighthouse. So when the angle of depression for the first ship, suppose this is the first ship, this is the first ship. Okay, angle of depression means if you draw a straight line parallel to this baseline, the angle that makes here is 36 degree. Okay, 36 degree. These two lines are parallel to each other, and this line is a transversal, means this angle should also become equal to 36 degree. Okay, so this ship is coming towards the lighthouse, and another ship is at an angle of depression 48 degree. 48 degree. Please note that the bigger angle should be closer to the vertical line. Okay, so this is 48 degree. Smaller angles should be farther away, bigger angles should be closer to the vertical line. As you go on moving towards the vertical line, the angle increases. So angle of depression in this case is 48 degree. Okay, 48 degree. This means this line is a transversal, so this becomes 48 degree equal, isn't it? So we understood the question. So the height of the lighthouse is given to us. This is A, this is D. Okay, this is 100 meter. Height of the lighthouse is 100 meter. I wrote A and D because I have A, B and C here, isn't it? So we are asked to find the distance between B and C, the distance between the two ships. This is first ship, this is second ship, the position of the first ship, the position of the second ship, distance between the two ships. Okay, so let us do this question. First of all, in this type of question, what we do is, first of all, we take the smaller triangle always. Okay, in triangle ACD, okay, ACD, in triangle ACD, the smaller triangle, AD equals to height of the lighthouse, isn't it? Height of the lighthouse, that is 100 meters, and we have angle ACD is 48 degree. Angle ACD is 48 degree, isn't it? Now applying tan theta, we can find CD. So tan of angle ACD equals to perpendicular, that is AD, by base CD, isn't it? This is perpendicular, this is base, this is angle, isn't it? So base is CD, or tan of angle ACD is given to us 48 degree equals to AD. AD means 100. We know the value of AD. This is given to us. CD unknown, so we write CD. Or tan 48, we do not know the value of tan 48, but we can use the trigonometric table for that. Okay, trigonometric table will be provided during the time of examination. So tan 48 means page number 455. You can see the value of tan 48, 1.1106. Tan 48, page number 455, tan 48, 1.1106. 1.1106 equals to 100 upon CD, isn't it? Tan 48 means this. Now let us cross multiply. CD comes here, this number goes to the denominator. CD equals to 100 upon 1.1106, isn't it? Or you can write this as CD equals to, you remove the decimal point. There is a decimal point before 4 digit. We remove the decimal point and we put 4 zeros here. Okay, 2 zeros were already there, 100, so we put extra 4 zeros, 1, 2, 3, 4 zeros. So we eliminate decimal point, 11106, 11106. Okay, so this is the value of CD, equation 1. Now we look at the bigger triangle, triangle ABD. In triangle ABD, we have AD. AD is common for both the triangles, isn't it? AD equals to 100 meter and angle is 36 degree. Angle ABD equals to 36 degree. Let us apply tan theta and find BD. Okay, tan of angle ABD equals to perpendicular AD by base BD, isn't it? So tan of angle ABD is given to us, that is 36 degree, equals to AD. AD means 100, isn't it? AD means 100. 100 upon BD. BD means BC plus CD. BC plus CD, isn't it? Or tan 36. Tan 36 means, so we need to check the trigonometric table, isn't it? Tan 36, page number 454, you can find the value of tan 36. Tan 36 means 0.7265. 0.7265 equals to 100 upon BC. BC is not known to us, this is what we are asked to find, plus CD. CD means we found 1 lakh, ones, tens, 100, 1000, 10,000, lakh, 10 lakh. 10 lakh divided by 11106. 1, 2, 3, 4, 5, 6. 2 zeros, 4 zeros, yeah. Divided by 1, 2, 3, 0, 6. Quite complicated task, isn't it? So let us bring this number here and this number to the denominator. Okay, BC plus 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 divided by 11106 equals to 100 is already there in the right hand side. We take 0.7265 the denominator, 0.7265. okay, we remove this decimal point and we introduce zeros here, 1, 2, 3, 4 zeros. Now, or we are asked to find BC, isn't it? BC equals to 1, 2, 3, 4, 5, 6 divided by 7265 minus this number goes to the right hand side, 1, 2, 3, 4, 5, 6 divided by 11106. 1 2 3 0 6. Okay, 11106. Now let me continue here. Please take the screenshot. Quite complicated calculations, isn't it? BC equals to, we take this 10 lakhs common. Okay, 1 2 3 4 5 6, 10 lakhs is taken common. Okay, so now we have 1 upon 7265 minus 1 upon 11106, isn't it? So our BC equals to 1 2 3 4 5 6. The LCM of these two numbers is 7265 into 11106 whole upon this number multiplies with 1, isn't it? So 11106 minus this with this 7265. So or BC equals to 1 2 3 4 5 6 into 6 minus 5 is 1. So this becomes 0. 0 means 10. 10 minus 6 is 4. This becomes 0. 0 means 10. 10 minus 2 is 8. Okay, this becomes 0. This becomes 10. 10 minus 7 is 3. So this becomes 0. 3841 divided by 7265 into 1106. 1106. 1106. Okay, or BC equals to, let's multiply this, 3841 1 2 3 4 5 6 zeros, 1 2 3 4 5 6 zeros. This two we have 7265 into 11106. So if you cancel this, you get 47.60 around. So 47.60 means 48. Okay, we round up because the number after decimal point is greater than 5, so we round up this and we add here 1. Okay, 47 plus 1 becomes 48. 48 meters. Okay, BC equals to 48 meters. If the number after decimal point is below 5, suppose 4, then we write only 47. Since this is 6, which is greater than 5, if there is 5 also, we can write 48. If 5 or greater than 5, we write 48. Okay, BC is 48. BC means distance between the two boats. Okay, two ships. Therefore, distance between two ships, distance between two ships equals to 48 meters. Okay, so this is the answer for question number 1. Now let us do question number 2. The ships are on the opposite sides of the lighthouse, isn't it? That means this is the lighthouse, so this is the water body. One ship is here. Okay, let us assume one ship is here, and the angle of depression here is, suppose, 48 degree. Okay, suppose this is 48 degree, this means this becomes 48 degree, and another ship is at this point, opposite side of the lighthouse, isn't it? So angle is 36 degree in this case, means this angle is 36 degree. Okay, so we are asked to find the distance between the two ships, and the height of the lighthouse is 100 meters. What we do is A, B, C, D. From triangle ABC we find BC, okay, because we have perpendicular, we have angle, we can find BC. From triangle ACD, we have perpendicular, we have angle, we can find CD. So we add up BC plus CD, so the distance BD, distance between the two shapes, can be found. Okay, so in triangle ABC, AC is the height of the lighthouse, that is 100 meter, and angle ABC equals to 48 degree, isn't it? So tan of angle ABC equals to perpendicular AC by base BC. Okay, so tan of angle ABC is tan 48 degree, isn't it? Now you can write 48 this side also, that side also, whichever side you wish, you can write that. Tan 48 degree equals to AC is given to us, that is 100, isn't it? BC we are asked to find, or we need to find BC, okay, not AC, BC. Now what is the value of tan 48? We have seen the value of tan 48, isn't it? Tan 48 is page number 455. The value of tan 48 is 1.1106. 1.1106 equals to 100 upon BC, or BC equals to 100 upon 1.1106, isn't it? Or you can write this as BC equals to, we remove the decimal points from the denominator and we introduce zeros in the numerator. Okay, 2 zeros were already there, so we add 4 zeros, 1 2 3 4 zeros, and we remove decimal point 11106. okay, there was a decimal point before 4 digits in the new denominator, so we remove the decimal point and we introduce 4 zeros in the numerator. So this is equation 1. Now we find CD from triangle ACD. Okay, in triangle ACD, AC equals to 100 meter, isn't it? And angle ADC equals to 36 degree. Tan of angle ADC equals to perpendicular is AC, common for both the triangles, by base is CD. Okay, or tan of angle ADC is given to us 36 degree, isn't it? AC means 100 upon CD means we need to find CD, isn't it? CD. Or tan 36, the value of tan 36 is, the value of tan 36 is 0.7265. 0.7265 equals to 100 upon CD, or CD we bring to the numerator in the left hand side, equals to 100 upon 7265. We remove the decimal point before 4 digit in the denominator and we introduce 4 zeros in the numerator, 1 2 3 and 4 zeros. Okay, so we found CD. This is equation 2. We found CD and we found BC. So the distance between the two ships are BC plus CD, isn't it? So therefore distance between two ships, distance between two ships equals to BC plus CD. BC plus CD gives us BD, isn't it? So what is BC? BC is 10 lakh by 11,106. 1 2 3 4 5 6 divided by 6 zeros. 1 2 3 4 5 6 zeros divided by 1106. 11106 plus 1 2 3 4 5 6 divided by 7265. 7265. Okay, 1 2 3 4 5 6 is taken common. Now within the bracket remains 1 upon 11106 plus 1. This is taken common, so 1 remains in the numerator, divided by 7265. So this gives us 1 1 2 3 4 5 6. LCM is 11106. This is 6. Okay, 11106 into 7265. Now we multiply this, 7265 plus this 11106. So we add up the numbers, equals to 1 1 2 3 4 5 6. We add up this number, 6 plus 5 is 11, 0 plus 6 6 7, 1 plus 2 3, 1 plus 7 8, and this 1, isn't it? 6 plus 5 11, 6 plus 0 6 7, 2 plus 1 3, 7 plus 1 8, and this 1. Okay, in the denominator we have 11106 into 7265. Now we multiply this. This into this, 18371, 1 2 3 4 5 6 zeros, 1 2 3 4 5 6 zeros, divided by 11106 into 7265. Cancelled, we get 227.68. okay, so this is around this 0.68, isn't it? 0.6 is greater than 5, so we round up this number, 228 meters. So distance between the two shifts in this case, when the shifts are opposite to the lighthouse. Okay, distance between the two shifts is distance between the two ships equal to 228 meters. Okay, question is very simple, but the new calculations, isn't it? The calculations is very boring. 5. Two pillars of equal height stand on either side of the roadway, which is 150 meter wide. At a point in the roadway between the pillars, the elevations of the top of the pillars are 60 degree and 30 degree. Find the height of the pillars and the position of the point. Okay, so these two are the pillars. Let us assume these two are the pillars, and there is a road in between the two pillars. Okay, that means the width of the road is this, isn't it? Suppose somewhere here is a point, and the angle of elevation of the top of the pillars from this point, okay, from this point is, number 1 is 60 degree and number 2 is 30 degree. Suppose this is 60 degree and this is 30 degree. Okay, this is 30 degree. Just an assumption, from this point at the middle of the road, not exactly at the middle, somewhere in between the two pillars, okay, on the road, when observed the first pillar, the angle of elevation is 30 degree. When observed the top of the second pillar, the angle of elevation is 30 degree. So we are asked to, and the width of the road is 150 meter from this point to this point. Distance between the two pillars is 150 meters. Okay, width of the road is 150 meters. So we are asked to find the height of the pillars and the position of the point. Okay, so let us write, this is A, this is B, this is B, this is C, and this is D, and this is E. Okay, now 150 meter is the total BD from here to here. BD is 150 meters, isn't it? So in triangle, so let us suppose BC is X. Okay, let us suppose BC is X. That means CD will become 150 minus X, isn't it? Obviously, because total BD is 150. If BC is X, CD will be 150 minus X. Okay, we are asked to find the heights of the pillars and the position of the point, okay, that is x. Okay, now let us solve this. Let us first observe triangle ABC. In triangle ABC, we have AB is the height of the pillar. AB equals to height of the pillar, height of the pillar, okay, and BC equals to base, isn't it? BC equals to x. Say we are supposing BC equals to x, and angle is given, angle ACB, C should be in the middle, okay, ACB is 60 degree. So let us apply tan theta and find AB, okay. Since tan of angle ACB equals to two pillars of equal heights, means these two pillars are of equal heights, okay. Tan ACB equals to perpendicular is AB, isn't it? Perpendicular is AB by base is BC, this is BC, or tan of angle ACB is 60 degree equals to AB. We don't know the value of AB, so we write AB by BC. BC is x, isn't it? BC is x, or tan 60 means root 3 equals to AB upon x. Therefore we have AB equals to root 3 into x, okay. This is equation 1. AB means the height of the pillar. So height of the pillar is root 3 into x. If we know the value of x, we can find the height of the pillar, okay. So from triangle ECD, another triangle, in triangle ECD we have ED equals to height of the, ED equals to AB, isn't it? AB and ED are same because two pillars are of equal heights. ED equals to AB equals to height of the pillar, height of the pillar, okay. And CD equals to total, BD is 150, BC is x, means CD is 150 minus x, 150 minus x, okay. So and angle ECD, this angle equals to 30 degree. Applying tan theta, since tan of angle ECD equals to perpendicular is ED by base is CD, isn't it? So tan of angle ECD is 30 degree, and ED is we have found ED equals to AB equals to height of the post, ED equals to root 3x, isn't it? ED can be written as AB because ED and AB are equal. Two pillars are of equal heights, ED and AB are equal, and AB is root 3x. Instead of ED, I can write root 3x, okay. So CD is 150 minus x, or tan 30 means 1 upon root 3, isn't it, equals to root 3x upon 150 minus x. So let us cross multiply. 150 minus x into 1, 150 minus x equals to root 3 into root 3, 3, root 3 into root 3, 3, this x remains here. So 150 equals to 3x minus x goes to the right hand side plus x. So 3x plus x is 4x, isn't it? Or 4x equals to 150, isn't it? 3x plus x is 4x equals to 150, or x equals to 150 upon 4, means 4 1s are 4, 4 3s are 12, 13, 14, 15, 3, 30, 4 7s are 28, 29, 30, 2.0, 4 5s are 20, or x equals to 37.5, means the position of the point is 37.5 meters away from the first pillar, okay. And from the second pillar 150 minus this, okay. Now let me erase this. I will find the height of the pillar, okay. So height of the pillar is according to equation 1. From equation 1 we have, from equation 1, we have AB is the height of the pillar, equals to root 3x, isn't it? Root 3x. So AB equals to root 3 means 1.732 into x means 37.5, isn't it? 37.5. So let us multiply this. 1.732 into 37.5. 5 2s are 10, 5 3s are 15, 16, 5 7s are 35, 36, 5 1s are 5, plus 3, 8. 7 2s are 14, 7 3s are 21, 22, 7 7s are 49, 50, 51, 5, 7 1 7, plus 5, 12. So this is gone. 3 2s are 6, 3 3s are 9, 3 7s are 21, 3 1s are 3, 4 5. So this is 0, 6 plus 4 10, 6 6 12, 13 14, 1 15, 8 9 17, 18, plus 1 19, 2 plus 1 3, plus 1 4, 5 plus 1 6. So decimal point before 1 2 3 4, 1 2 3, 1 2 3 4, 64.95, 64.95 meters. Okay, therefore distance, height of the pillars equals to height of the pillars equal to 64.95 meters. Okay, and the position of the pillar point is 37.5 meters. Okay, I hope you got this. Okay, thank you so much. This was for today. I'll continue the rest of the questions in the next video. Okay.